Hello everyone, it's Les again, checking in from my home to yours. Thanks for following Listens Working From Home with SoundCheck video series. We hope it's been helpful in giving you some good ideas for making the best of your work from home time. I've presented a few work from home videos on the SoundCheck 18 demo version and the process for upgrading to SoundCheck 18 from a previous version. In this video, I'll tour you through the new features in SoundCheck 18. SoundCheck 18 adds new features with an emphasis on automation and simplicity. New additions include improved automation, plug-and-play with Listen hardware, simplified gain control, improved sample rate management, new digital I/O control, MEMS interface control, TED support, and Wasapi drivers support. Let's take a look. SoundCheck has supported external control via TCP/IP for several versions. This is a powerful capability to externally control SoundCheck from any platform and any programming language. If you're interested in external control, review the TCP/IP section of the user's manual and explore the installed external control examples. The new sequence parameter feature allows you to pass test configuration data to the memory list from external programs using TCP/IP. For example, you can store parameters like limits, test level, and test signal externally, so a single sequence can be used for multiple products. This simplifies your sequence and number of sequences to maintain, particularly useful on the production line. I'm going to run an example automation sequence from a Python script. This sequence and script install with SoundCheck 18 and provides an example of this powerful capability. Before I run the script, note there are parameters that I can change in the sequence, including test level, start frequency, stop frequency, and limits. I'll run the script and we'll take a look at our sequence. The magic happens in the Configure Sequence window. You can now define sequence parameters that save to the memory list. Once defined, SoundCheck can use these parameters in a sequence step. In this case, test level, start frequency, and stop frequency are used in the stimulus step. I'll lock the X and Y axis of the graph and run again so you can clearly see how we can easily change sequence parameters on the fly with a Python script. I'll change test level, start frequency, and stop frequency, and note how the graph updates and the memory list values take direct input from the script. There are many use cases for this feature. The obvious is that you can maintain a single test sequence and run separate scripts for different models of your device under test. You can also define your own memory list items and perform conditional steps in your test sequence. This is an often requested feature, and we're proud to offer it in SoundCheck 18. SoundCheck 18 now supports true plug-and-play with Listen and Portland tool and die hardware. Setup is much faster, especially in production setup environments. With true plug-and-play, configuration time is minimized, particularly with multi-channel audio interfaces. Input and output channels will auto-populate with parameters such as sampling rate and calibration values. Hardware items are stored and immediately recognized when connected, and SoundCheck will default to the connected device. When substituting devices of the same type, previous configurations are reused and sequence configurations do not need to be updated. For example, in this configuration, I can connect a different AMP Connect or DCC 1448, and SoundCheck will auto-detect the hardware and map channels accordingly. This means you can save a hardware configuration and load it onto multiple test stations for faster deployment. You can also easily move Listen hardware between test stations. Simplified gain control with the supported Listen interface has been added for faster development time. Auto-read and auto-range settings are accessible as drop-down options in the gain menu of the acquisition editor. Auto-read will auto-adjust gain based on manual input from the user. For example, I'll run the sequence with the acquisition set to auto-read, and I'll manually set the input gain on my AMP Connect to -20 dB. When I run the sequence, SoundCheck will report the max FSD, the digital headroom of the audio interface. I'll adjust the gain and note how the level changes. Auto range automatically identifies the correct gain to optimize your measurement signal to noise. Auto read is also available in virtual instruments. Whether in an acquisition step or virtual instrument, you can quickly adjust gain without the need for a hardware message step, saving valuable development time. Improved sample rate management makes testing with different sampling rates in SoundCheck faster and easier. Many audio interfaces have latency that is dependent on sampling rate, and SoundCheck improves communications with these devices. Users can specify latencies for various sampling rates, either by entering manually or importing from a file. Then, SoundCheck will automatically use the correct latency for the specified sampling rate. Lastly, when using WAV files, you no longer have to manually set sampling rate to match the sampling rate of the WAV file. This makes it simpler to switch between WAV files and useful for anyone making measurements using stimulus wave signals like speech or music. AmpConnect's digital I/O ports can be used for communicating with relay boards, lighted pass-fail indicators, foot switches, and other devices. And SoundCheck 18 digital I/O controls have a separate message step. This means that all controls for I/O settings are completely separate from other AmpConnect settings, minimizing the possibility of other parameters such as gain or routing being accidentally modified. The new settings offer a uniform appearance and switching scheme across all devices with digital I/O control, so that sequences written, for example, with NI hardware, are easily converted to work with AmpConnect. The Portland Tool and Die MEMS microphone interfaces can now be fully controlled from within SoundCheck. This offers faster setup of the measurement interfaces with SoundCheck, as well as greater measurement reliability, as the device settings can be built into the test sequence. Sequences using the R&D grade DCC 1448 interface will also work seamlessly with the production grade PQC 1448, making it much simpler to transition sequences from the R&D lab to the production line. TED's support with compatible Listen hardware will enable automatic identification, configuration, and calibration of TED's microphones and accelerometers, saving time on initial hardware setup and whenever hardware is changed. SoundCheck 18 now includes Wasapi driver support in Windows 10. This driver offers fully multi-channel support, allowing each individual channel to display separately in the hardware editor rather than as channel pairs. As always, SoundCheck 18 is available to registered users with an active support contract. If you wish to upgrade, now is a great time with Listen's discounted upgrade pricing for a limited time only. Visit the news section of listeninc.com and contact your Listen sales engineer or rep for a quote. Thanks for watching and stay safe.